So welcome to my walkthrough for the OCR Higher Maths GCSE paper from the Summer 2023 series. It's their paper 5, the middle paper for OCR, and that means it's their non-calc, so let's get on with it. Question 1. When you're dividing fractions, first of all, you always want them to be in this case, in top heavy. The 33 over 35 can stay as it is. You need to change this. It's a mixed fraction. Get rid of it. Make it top heavy, improper, whatever you call it. I do big times bottom, 1 times 7. Add the top. There we go. Then you can apply your KFC, whatever you call it, KCF, keep, flip, change, whatever you call it. Keep the first fraction, change the divide to a times, and flip reciprocal. Now we've got top times top, bottom times bottom, and then you can cancel down. But I prefer to do pre-cancelling, which means if anything from the top and anything from the bottom across, for example, like here, 33 divides by 11, 11 divides by 11. And you could proceed, it's now simpler, but I'm also going to divide the 7 by 7 and the 35 by 7. So now when I apply top times top and bottom times bottom, because nothing else would cancel, it's already in its simplest form, so pre-cancelling's a winner. Otherwise you'd be having 35 times 11. You're up in 3 digits, you're beyond your times tables. For me, makes life a lot more difficult. So yeah, any application of KFC and top heavy for a mark, KFC for a mark, fully simplified answer for your third and final. On to number 2. What you've got here is 2 transversals. That means there's 2 lines crossing the parallel lines. You take each one in turn. You can almost treat this as 2 separate questions, except it makes the B a bit hidden. Anyway, so we can focus on the left-hand part. We can focus on that. And as you can see, A is in the top left. 125 is in the top left. So first of all, A is 125 because corresponding angles are equal. And I always write these out in full on my model answers. Can't be bothered doing it twice on here. Feel free to use your own words, phrases, or whatever your teacher has nagged you to do. But it's 1 mark for that, 1 mark for the good sentence that makes sense. But you need to get across keywords, corresponding angles, and equal in whatever phrasing you want. Work out the value of B. B is the apex here. B is the top angle. So first thing I would do is use your diagram. Alright, if that's 75, so is that. But so is that inside. They're all 75. They're all acute. They're all on the same transversal. On the left-hand side, angles on a straight line. We've got the 125 already. Straight line makes 180. So the internal angle is 55 degrees. And now it just boils down to angles in a triangle make 180. If we add together what we know, we get 130, and 100 minus that gives us B. 1 mark for the correct answer, 1 mark for any good step towards getting the correct answer, for example 75 or 55, and 1 for another step, either doing 180 minus or for getting both internal angles. It depends on how much you've shown. It doesn't really ask for any reasons or even any working out, so don't forget, answer only will score full marks. Number 3, we're dividing by 0.02. The best way to do this is, first of all, multiply both numbers by 10. That doesn't quite get you there. what you want to do is multiply it by 10 again, and you're ending up with 380 divided by 2, which is basically 380 halved. 190, job done. Another way of thinking about it is 3.8. You could have done, you might have a teacher who preferred you to say, nope, go into fractions, because you've got 38 over 10 divided by what is actually a 50th. And you can actually do KFC again, as in question 1, with a bit of pre-cancelling, but I wouldn't do that, not for me. When you are dividing by a decimal, multiply both numbers by 10, 100, 1,000, whatever it takes to get that number the same. And I will also say, don't forget, these 3 questions, there's no need to adjust the answer. These 3 questions, check it on your calc if you need to, if you don't believe me. They all work out to be 190. Number 4, got quite a waffly one here. All waffly questions should be taken one line at a time. Top line, the diagram shows a prism. Length 10 tells us nothing that's not already on the diagram. It's just extra waffle. The cross section is a right angle triangle. Extra waffle. The base B is 2 centimeters longer than the height. Stop right there. If the base is 2 centimeters longer than the height, we can straight away replace B with the height with 2 added onto it. Then that's done. The volume of the prism is 240. If you do volume divided by the depth, you get 24, which is the area of the face. The face is a triangle. We can say it's a half base times height, which obviously we've replaced the B with H plus 2. Either way is fine. A student is explaining how they worked out the value of B. They say B is 6 because that means H is 4. 6 times 4, and there they go. That's how they've got their 24 by doing 6 times 4. Sounds fine. Hold on. They've forgotten about the half, because the idea is a half of the base times height is 24. Doubling everything means 48 should be equal to base times height. And there you, as you say, they've got a difference of 2. So they've got the difference of 2 correct. That's fine. But there we go. The error is they've missed out the half from the formula of a triangle. As you can see, to work out B, you can now go back to this little phrasing here. For 2 numbers to have a difference of 2 and multiply together to make 48, it's got to be 8 sixes, where H is shorter than B. B is longer, so B takes the higher of the 2 values. So for 3 marks, you're getting 1 mark for spotting the mistake, 1 mark for the answer, and your 3rd mark is for anything on your diagram or extra on the dotted lines, anything towards good method for working out B. Give yourself the mark. But again, if you've got the right answer with a decent reason, give yourself 3 and don't worry too much about it. 5 good old scatter diagrams, starting off with part A. You've got to plot the unshaded 4 points. Not as easy on this as it is on paper, so fingers crossed for me. Hopefully yours is more accurate than mine, so here we go. 5 along, 1.14 up, 1.1 and a couple more. I'm going to hope it's there. 7 along, 1.24 up. There's 1.2, so again, more in hope than in expectation. 9, 1.26. There's 9, 1.24. So I'm just going a little bit above my previous. And finally 14, 1.68 is thankfully dead easy. It's almost in the top right hand corner. Part B then says, describe the type of correlation. Although it's given you a full line, it's only asking you to describe the correlation. It only needs that one word, positive. It's not asking you to describe the relationship. It's not asking for any waffle linking the height to the age. It's only asking for correlation. It needs that word positive. One of these children is taller than expected. That's that one. Slightly not quite following the general trend. Not necessarily a massive outlier or anything like that. Just not following the usual trend. On to part D. I'll stay on this page though. Part D says Kai is 8 years old by drawing a line of best fit. Now, in case you've wondered, how do examiners mark it? Do they have an overlay or whatever? Some do. Some will create an overlay. Some exam boards do indeed use overlays. In OCR, they recommend to the examiner about what's called gates. So what I mean by that is there is a gate at 2 along, 0.8 up. So if I put a little sort of dash there, and then above that it's at 0.94, like so. And there's an upper gate that's at 13, and that's roughly about 13 to 1.66 and 13 to 1.54, I think it is. Yeah, and there we go. So the idea being, as long as your line passes through the gates. So if I just get my trusty ruler, that would be classed as good enough, as in it goes through both gates and slightly beyond. What you're not allowed to do is either miss a gate, that means you lose that mark. You can still pick up follow through marks, or what some students sometimes lack is, I'm afraid, they don't quite go far enough. I always say to my students, when you're drawing a line of best fit, go right to the end of the graph paper on the upper and go close to the y-axis on the lower. You don't necessarily touch it, no point in that. But as long as you're going through those gates, following the general trend, it's going to be fully correct. On to the next part. It did say we need to estimate Kai 8 years old. Again, grab your ruler. There's Kai at 8. Up you go. And along you go. And again, they allow any sort of follow through from your line of best fit. So on my other one, I think I came out with a height of about 1.25. As you can see for this one, it's closer to 1.3. So I'm going to put mine down here for 1.28. As I say, it will vary from your line of best fit, so just make sure it follows through and all them marks are yours. Describe an assumption you have made, and the assumption is that Kai follows the general trend. He's no kind of outlier. So I would just say, yeah, exactly that. My assumption is Kai follows the general trend of the other students, if you want to do a bit more. Anyway, explain why using this data for the height of a child that is 17 years old may be unreliable. Well, I would go back to my graph and it's the old, they do it quite a lot. The oldest child we have here is 14. Alright, so I would put any explanation as data available is only up to and including 14-year-olds. Essentially, it's something called poor extrapolation. You can't extrapolate it. Just say something like 17 is beyond the range of data available. By quite a way. It's not like you're estimating a 15-year-old. 17's quite a way above. Again, though, with these wordy, give you reasons why. Do not overcomplicate. It's only worth 1 mark. I would just stick with no data available for children above 14. Number 6. Quite a weird way. Long bit of waffly. Alright, have a little read. Taylor has a full bottle of medicine. No one cares. But it does hold 20 doses. Yeah, whatever. Each day, Taylor takes 1 dose. After 8 days, there are 880 left. Right. There were 20 doses. 1 a day, 8 days gone, means that 12 doses are left. Those 12 doses are worth 180 millilitres. You need to work out how much 1 dose has. So you can either cancel down both sides and do 6 to 90, or you could obviously divide 180 by 12. Whatever method you use, you should end up with 1 dose of the medicine being 15 millilitres. Work out how many millilitres were in a full bottle. 1 dose is 15. Back to the question, we need 20 doses for a full bottle. So we're going to times it by 2 and then times it by 10. 300 mils. Now, a variety of ways of doing that one. So Mark's scheme a little bit all over the place with how many methods you can get. Obviously, it's the old one for the answer, one for 1 dose, one for getting close to getting what 1 dose or something that goes in. Because you could have found 2 doses and times it by 10. Could have found 4 doses, etc., etc. But 1 for a setup, 1 for getting nearer, 1 for getting really close, and 1 for the answer is about as simple as a way of looking at it as you need. Number 7. Volunteer packs boxes for a charity. Yeah, not bothered about the context. What we are bothered about is 5 boxes equals 45 seconds. Use this information to show they can pack 55 boxes in less than 9 minutes. We've got 5 boxes. We want 55 boxes. That's multiplied by 11. We'll get a mark for that logic. We obviously, therefore, need to do 45 times 11. Whether you can do that mentally, use the quick way of timesing by 11 because it is split the numbers and add them to make the middle. You're getting 2 out of 4, but not forgetting that is in seconds. They've asked you to show 9 minutes. 9 minutes, as you probably know, you could convert that to 540 seconds, or you could go this way and say that 495 is indeed 8 minutes, 15 seconds, and obviously anything wrapping it up to get you full marks. And the old assumption for these type of questions is that the person, the volunteer, can continue to pack at the same rate or apply any common sense. For example, they don't get tired, they don't slow down, they don't speed up. Any words to that effect will be good enough to get you the simple mark. Again, like all these, don't be tempted to fill in more lines down here. Waste of your time, and examiners don't want to read all that waffle either. Number 8. Block is, as soon as I see the word block, my brain just goes to, is this a surface area question or is this a volume question? And as soon as it mentions density, I know it's going to be a volume question. Density, mass, volume, D, M, V. Start thinking about it. Use estimation. Okay, the block is 3 centimetres by 5 centimetres by 2 centimetres. It's 30. The density, the D, is actually 8. Sam thinks that the mass is about 2.4. To work out mass, you would do density times volume. Always worth writing it down when it's a show question. Show how you decide. D times V is 30 times 8. It's 240 grams, because the density was in grams per centimetres cubed. The block was in centimetres. The mass, therefore, is in grams, and if we convert that, that's actually 0.24 kilograms. What a rubbish K. Let's have another bash at that. There we go. Use estimation to decide if Sam's answer is reasonable. Sam's answer is not reasonable or unreasonable because 2.4 kilograms is 10 times 0.24 kilograms. Or words to the effect of, they're out by a factor of 10. So you get a mark for all your waffle downstairs, and for upstairs, estimating, give yourself a tick. 30 is the other one. Then obviously using your DMV correctly and converting to something comparable, whether you might have kept it in grams and converted the kilograms. Either way, one for getting them into a comparable form. And there's your 5th mark down the bottom. So number 9, I'm not really a fan of part A. It's a little bit on the tricky side. It's non-standard. Usually they ask you to take a ratio, maybe transfer it into a fraction. But this one's actually drilling a bit more down on the relationship between the 3 and the 2. So we've got antelopes and zebras, 3 to 2, which obviously could be 30 to 20 or something like that. But it's asking you for the number of antelope as a percentage of the number of zebra. If we've got 20 zebras, there's an increase of half to go to the antelope. If you want to increase something by half, the original amount is 100%, add on the half, yep, it's 150%, and that is the right answer. Another way of looking about it is to say, how do you turn the number 2 into 3, or 20 into 30? And that's a multiplier of 1.5, which when you connect the dots, times it by 100 to go from decimal to percentage, it also gets you to the 150. And another way of looking at it is to say number of antelope, which is 3, as a percentage of, means out of or over, is 3 over 2. And yep, that's another way of getting your 1.5, which again becomes your 150%. But not a fan, got to be honest. Bit more of a fan of B. It's a connected ratio. Find the connection, find where they sort of meet in the middle. Get it organised first of all. Antelope to zebra to meerkats. A to Z is 3 to 2. They've reversed it. Meerkats to zebra. So zebra to meerkats is 3 to 7. The sneaky little you-know-whats. Part B, there are 15 more meerkats than antelope. We are wanting there to be a difference of 15. But before we worry about that, let's make these in a comparable form. We need zebras, they're the connection, meet in the middle with a value of 6. So for 3 to 2, we need to treble both. For 3 to 7, we need to double both. But now we have indeed got our connected ratios. At the moment, from antelope to meerkats, there's a difference of 5. We're wanting a difference of 15, which is 3 times larger. We need to multiply all the animals by 3. That'll give us 27. That'll give us 18. And that will give us 42. If we needed all that info, for example, like total number of animals, we actually don't. We're only interested in the zebras, and there's 18 of those. In we go for that 6 marker. Number 10, a little bit more waffle. A student draws 2 different regular polygons. Now I would stop right there. They've given you a full page for this. I know the answer box is there, but you are allowed to write down the bottom. So yeah, they have indeed given us a full page for this. Why not sketch it out? That could be a polygon. That's the internal, and that's the external. We've got another polygon. Draw it slightly differently. Internal and external. Now, I'm sure some people might have drawn the whole thing. No point. Alright, but feel free if you really wanted to. But we've dealt with the top 3 lines. It's not till the 4th and 5th line that some algebra can actually kick into play. The sum of P and Q is 112. P plus Q equals 112. The difference between P and Q, difference means subtract, is 32. If you're worried about which way round they are, doesn't actually matter. You'll just get the answers. As I say, does not matter. The 2 answers could be reversed. Not a problem. It is a hidden simultaneous equations question, but thankfully you don't have to manipulate. No need to times by 2 or 3. As you can see, in both equations we have 1Q and 1P. So it's entirely your choice as to whether you subtract or add. I chose to add. P plus P. Q's disappear because it's same signs subtract to make them disappear. Opposite signs add. That's why they disappear for 144. Meaning that P is 72. But don't forget, P minus Q is 32, so if one of them has an angle of 72, they must, let's go for that one, they must add up to give 112, so Q therefore will be 40. But that's not finished yet. You have indeed found the external angles, great. Find the number of sides, they've put it in bold. Find the number of sides of each polygon. That formula, the number of sides is equals to 360 divided by the angle. And the number of sides for the other one is 360 divided by the angle. And what we've done there is just rejigged. I'm sure the formula you've seen before is actually in a slightly different form, where that is that the exterior angle is 360 divided by n. We've just flipped them around. Anyway, 360 divided by 72 is 5, and 360 divided by 40 is 9 in any order. You get a couple of marks for coming up with the equations, 1 mark for elimination, 1 mark for good attempt to solve, and there's your other 2 for your big 6 marker. Number 11. On paper 4 there's already been an inverse proportion. This one's now a direct proportion, but without any numbers that you might like to have, but the process is the same. Don't bother with the fish symbol. I said that on the video for paper 4. Just write down y is directly proportional, means multiplied by the square of x. Now, find the percentage decrease in y when x is decreased by 30%. Here's your logic. If you want to decrease a number by 30%, you have a multiplier of 0.7. You need to replace x with 0.7. X, like so. 1 for the setup, 1 for the substitution. Let's do the maths. 0.7 squared is 0.49. We're actually going to consider writing that as 49 hundredths. Or in other words, let's stick to 0.49 actually. And that gives you a massive clue. Find the percentage decrease in y. So as you can see, k is consistent throughout. K is an unknown value, doesn't change, it's what's in front. It's that. So x squared has gone from having a 1 in front of it to having a 0.49 in front of it. That, folks, is a reduction of 51%. If you want to reduce something by 51%, you multiply it by 0.49. So yeah, they are weird, those questions where you aren't given any values, but that's how you go about it. Think about your multiplier, get it in there, and see if you can make sense of it. Question 12. We've got fraction sequences. All you got to do is say to yourself what's happening on the numerator side of things. As you can see, 2 to 5 to 8 to 11 going up in threes means there'll be a 14 on the top. On the bottom, bit less obvious, up by 5, up by 7, up by 9. You can only guess it's now going to go up by 11. 26. Oh, add on 11. 37. Need both of those numbers for a mark. So on to part B. Again, separate the numerator and the denominator into really two separate questions. Numerator-wise, it's going 2, 5, 8, 11. That's up in threes, 3n, and 3 times table needs looking at. And when we compare the 3 times table to the sequence we're interested in, it's -1. On the bottom, we've got second differences, as we can see, of 2, 2, 2. That means there's an n squared involved. Half of 2 is 1. So actually, if you want to be picky about it, it's a 1n squared, but who cares? 1n squared is just your square numbers. And we are comparing that to the denominators of 5, 10, 17, and 26. If we do a subtraction, we take those away. 5 minus 1 gives us 4, 6, 8, and 10. You can see there is another sequence generated, and you just basically reboot. Let's now do the nth term for the sequence 4, 6, 8, and 10. It's going up in twos. That's 2n, the 2 times table. The 2 times table goes 2, 4, 6, 8, and same process. What's happening each time? We are adding 2. 1 mark for top, 2 marks for bottom. Let's move on. Number 13. We've got right angle triangles. We haven't got a calculator, so it's going to be one of them which probably needs your old exact trig values knowledge. Work out the length of BD. I'll stick an X on there. You cannot use the left-hand triangle. There isn't enough information. You've got a 45-degree angle, but nothing else. So it's all about the right-hand side. A little sketch usually helps. Just to take it off the diagram, which has a little bit too much information. I'm a big fan of just keeping it simple like so. If I want to find x, well, I've got the hypotenuse. I want the opposite. This is a SO in SOHCAHTOA. To work out the opposite, we need to multiply the sine of the angle by the hypotenuse of 12. This is where your exact trig values come into play. Sine of 30 is a half, and a half of 12 gives you the 6. 1 for your trig knowledge, 1 for your exact values knowledge, and 1 for 6. Part B, work out the exact length of AB. Now, although it's given you a 45-degree angle, it's not SOHCAHTOA. The reason being, if that's 45, so is that, which makes it isosceles. So if that's 6, the bottom side is 6 as well. Work out the exact length of AB. I'll stick a Y on there. Yep, it's Pythagoras. Y is the hypotenuse, so it's the other two sides squared, added, square rooted. 36 plus 36 is 72. And let's now apply. It says simplest form. We need our laws of surds knowledge. We can split them up. The largest square number that goes into 72 is 36. And without a calc, we know what the square root of 36 is, but we don't know what the root of 2 is. Leave it alone. There's your 3 marks. Number 14. They've already drawn 2 of the lines on for us. Isn't that nice? The lines they've drawn, just so we know, they've drawn us x is equal to -3. And we're wanting x is less than. So we'll be interested in the region to the left of that line. They've also drawn us y equals x. We are interested in the region where the height y is less than or equal to -x. Height is underneath a line, so we'll be looking for the region on that side of that line. Now comes a bit trickier. It's in a non-standard way. They're not easy to plot. You could obviously do a table of values, but I'm more of a preference to add 1 to both sides. Yes, I'm ignoring the inequality for now. Y equals a half x, add 1. To plot that, y equals a half x, add 1. The intercept is 1. And what does a gradient of a half mean? Gradient of a half means you need to go along 2 squares in order to go up 1. Along 2, up 1. And that pattern will go that way around. Now, the difference is the line you are drawing has not got the equals to part of that line. Now, my little line drawing thing, I don't think will do dotted lines. As you can see, I'm only using the free version, so I can't do dotted lines. So I'm gonna have to draw a line like that. But rest assured, folks, I'm hoping. Oh, nearly. I am hoping that you can forgive me. The fact is, that should be a dotted line. Okay, that should be a broken line, if you want to call it that. Anyway, 1 mark for plotting it, 1 mark for it being dotted. Then you get 3 marks for shading in the fully correct region. So finally, let's just replace that. It should be y is greater than, which means we need the height to be above the line. Y is greater than means the height needs to be above said line. The region which satisfies all 3 arrows I've drawn is that region there. It's to the left of that line. It's underneath the y equals -x line, and it's above the quote-unquote dotted line. There's 3 marks for shading in the correct region. And the way the mark scheme works, by the way, they give you like 2 marks if you put the R there, or 2 there, and 1 there, and 0 there, and so on and so forth. But don't worry about that. Get it fully right. It's not the worst 5 marks in the world. I know people don't like graph inequalities. Get used to them, they're not too bad. If you can plot y equals mx plus c, you're halfway there. Right, some proper algebra. Here we go. Factorise this. Now it is a quadratic. It is in the quadratic form, despite the fact there are 0 x's in the middle. There are indeed 0 x's in the middle, we just don't write them. The reason why I'm making a big deal about that is because when it's in the quadratic form, it's 2 brackets, not 1. Also, 9 is a square number, x squared is a square thing, 4 is a square number. It's your old friend, the difference of 2 squares. Square root of 9x squared is 3x. Square root of 4 is plus and minus 2. And that's what goes in those brackets for your 2 marks. You would score 1 mark for anything that's where you've made one mistake, like if you've done 3x plus 1 and minus 4. In other words, you're nearly there, but you're not quite right. Part B, solve by factorisation. I normally skip the AC method on these videos. I'm going to do it properly here, so if you don't want to see it, skip ahead for 2 minutes. Anyway, A is 3, C is negative 8, so AC is negative 24. I always like to create a bit of room. Move the 3x squared left a bit, move the minus 8 right a bit. Now's when you rack your brain. We need to think of 2 numbers which multiply together to make negative 24, but add together to make negative 2. Rack your brains, eventually you'll realise it's minus 6 and it's 4, and you can put the minus 6x and plus 4x in any order you want. It will still work. Next, factorise the left-hand side. They're in the 3 times table, and they both have an x in them. 3x times x is 3x squared. 3x times minus 2 is minus 6x. Right-hand side, get that factorised as well. They're both in the 4 times table. That's the only thing which comes out, leaving you with x minus 2 in the brackets, and the fact that those brackets repeat tell you that you've smashed it, and the leftovers are your other bracket. Change the side to get one solution, change the sign, and divide by the coefficient of x to get your second solution. It's a couple of marks for solving, one for solving but with an error, and one for your answer. Alright, one for a decent attempt at solving, 2 for a proper good, fully corrected solving, and 1, I know they add up to 4, it's not what I mean. Anyway, I'm waffling. Number C, nearly said it. Right, left-hand side, I'm going to expand the brackets on the numerator. 2 times x, 2 times negative 5. Denominator-wise, I'm going to multiply both sides by 1 minus 3x. So on the right-hand side, I'm going to skip a stage. I'm going to also expand the brackets. Now it's a case of collect your x's all together. Let's add 6x to both sides, whilst adding 10 to both sides. Just need to say a couple of algebras, get in there, and now divide both sides by 8. You can leave your answer like that. You can cancel it down to 3 over 2, 1.5, 1.5, God knows, loads of different things. It doesn't ask for simplest form, so no one cares. 16/8. 64 to the power of 2/3. When you have a fraction as a power, I like to think of it as the top number. The numerator makes it bigger, the denominator makes it smaller, And when you haven't got a calculator, you should make it smaller first. The cube root of 64 is 4. Now you need to square it to get 16. 1 mark for any good method, 1 mark for the final answer. Flipping heck, I've pressed the wrong button. Never mind. On to part B. Oops, bit too big. There we go. So we need to have a fraction plus 0.13 recurring. Now, before we start worrying about how it's phrased, let's actually do the old x equals 0.13 recurring, multiply both sides by 100, and we've achieved what you need to do when you're getting rid of recurring decimals. Anything that comes up after the decimal points now repeat. So when we subtract, they cancel out. So all we've got to worry about is 13, take away 0, and we've got our value for x. It's 13 over 99. Couple of marks earned. But now let's worry about how this question's phrased, because it's written in a very weird way. Let's write it in a better way. P over Q equals 5/9 minus, because I'm basically subtracting the 0.13 recurring from both sides. It's become a hidden fractions subtraction. Let's take the first fraction, multiply the top by 11 and the bottom by 11, which means they're now of the same kind. We can subtract the numerators. That gives us 42 out of 99. Haven't finished yet. Find the value of P and Q, because it needs to be in its lowest terms. They're both in the 3 times table. Divide the top by 3 and the bottom by 3. They no longer have any common factors. You've got your answer. 1433. As I said earlier, you got 2 marks for getting that bit, 1 mark for rearranging or doing anything good with fractions, and 1 for getting the right answers. Number 17. Just before I go through the question, a reminder about some stuff you will have studied way back in year 7 or 8. A rhombus is a falling over square. I've drawn it rubbish, you know what I mean. All the sides are the same length. But the difference between a rhombus and a parallelogram is that the diagonals are perpendicular. That's one of the reasons why a rhombus has 2 lines of symmetry, but a parallelogram does not. So there we go. It's hidden in the wording of a rhombus. It's one of those questions, folks, where we do indeed have perpendicular gradients. One diagonal of a rhombus has that equation. Its gradient, it's in y equals mx plus c form. Its gradient is a half. The other diagonal passes through that point. So the other diagonal, negative reciprocal, flip it upside down, change the sign. The other diagonal will have a gradient of -2. We can now apply y equals mx plus c, but we can stick in the m is -2, the x is 1, the y is 7, and we're going to end up working out the c. So in goes the 7, in goes the mx, which is 1 times -2, and there we go. Add 2 to both sides. We now know what c is. Let me just put some ticks in. We now know what C is. We already knew what M was. We have the equation y equals minus 2x plus 9, and there's your fourth and final mark. Number 18, non-standard. Yep, in the way it's written. First thing I would do before I worry too much about its presentation, not a fan of radical notation. That means the surd symbol. Much prefer replacing. I'm going to write this the p term as p to the power of 2/5. And the m I'm going to replace as m to the power of the 3 on the bottom, so the 2 on the top. There we go. And we're being told that p equals m to the x. What's the clue? We want normal p on its own. We don't want p to the power of 2/5. Now what you can do here is you can get rid of the 2 on top, because that was squaring. If we square rooted it, it goes away on the left hand side. But that would also mean we're square rooting on the right hand side. When you're square rooting, you are raising it to the power of a half. That's what you're square rooting. Also, how do we get rid of the 5 on the bottom? Well, that's the 5th root. If you want to get rid of a 5 on the bottom, bosh, you raise it to the power of 5. But whatever you do to the left, you do to the right. Which looks very complicated, but don't forget, power to a power to a power just means multiply those powers. That's all it is. So when we want p equals, we're going to have m to that power. And you'll never guess what happens. 2 times 1 times 5 is 10. 3 times 2 times 1 is 6. And hey presto, it cancels down. Now it's worth mentioning, if you want a quicker way of doing this, let's just show you how to go about it. So let's pretend we've got it in that form, and we're going with the same logic. We want p equals. Now, to get rid of a power of 2/5, you basically multiply it by the reciprocal. You raise it to the power of the reciprocal, it's power to a power. It's multiply the tops, multiply the bottoms, you'll get 10 over 10, you'll get 1. Now you can't just raise the left-hand side to the power of 5 over 2 without raising, the right-hand side to the power of 5 over 2. And that's also another reason why 2 times 5 on top, 3 times 2 on the bottom, you end up at the same point, just a little bit quicker. So whichever way you prefer, it's one for any good method of writing it with fractions, and then one for getting rid, and one for showing clearly, preferably with a 10 over 6 method, where you've multiplied something along those lines. Number 19, a box contains 25 discs. Great. The discs are either blue or yellow. Stop right there. Blue to yellow, 4 to 1, and don't even read on. There's 25 discs. That means there are 20 of them and 5 yellow. 2 discs are chosen at random from the box without replacement. Find the probability. We've got different colours. Nice. Pretty straightforward, if I do say so myself. So when we pick them, we either get blue, then yellow, or we're interested in yellow, then blue. Now they'll just have the numerators switched around, so I can just do 2 times 20 over 25 times 5 over what will become 24. Now, if you're wondering why I can just do the 2, because if I did blue-yellow, it'd be 20 and 5 on top. If I did yellow-blue, it'd be 5 then 20 on top. It's the same thing. The order, yeah, doesn't matter. I can just double it. And now it's become a fractions question. I'm going to pre-cancel. I'm going to go 20 over 25, I'll write it over here, is really 4/5. Divide the top by 5, bottom by 5. Top by 4, bottom by 4. And now when I do top times top times top, I just get 2 times 1 times 1 is 2. 1 times 6 times 1 is 6. Oh, I missed a bit of pre-cancelling. I can do it now for a third. Marks-wise, one of them, one for there, couple for the rest, and one for your answer. On we go. Number 20, just don't forget with vectors, think of them as a journey. How do I get from one place to another place? Don't overcomplicate. So part A, it's really asking, how do I get from O to B? Well, there's O, there's B. I have forgot to put on A to N to B is 3 to 5, which makes that 3/8 of the line, and that 5/8. Anyway, O to B, I'm going to go to C first. That's that journey. And then I'm going to go along to B. And that top vector, it is the same size and parallel to A. We can just write it as A. So how do we get from O to B? It's vector C plus vector A. Part I, how do we get from O to N? Well, let's go along the bottom. We go from O to A first. That's letter A. Then we go A to N. Now, A to B is C. It's parallel because it's a parallelogram, so it's the same size and same direction. But really, these 3/8 and 5/8 are 3/8 of C and 5/8 of C. That helps us with part I because it's A plus the 3/8 of C, one for each bit. Now on to, obviously, a trickier bit. Let's have a read of it, then we'll come back to the diagram to do some thinking. CN is extended, reaches a point P, such that CP is 8/5 of CN. Show, using vectors, that we've got a straight line. Now let's think about the fact that we've already done a lot of CN. How do I get from C to N? I can get from C to N by going along here, which is A, and then down here, which is minus 5/8 of C. I'm now going to build it up. I'm now going to consider about C to P. Now I'm going to assume you've got a copy of that somewhere, folks, because now when we do the journey of C to P, we've already been told such that, so it's 8/5 multiplied by what we just wrote down, multiplied by CN. And what we wrote was A minus 5/8 C. Let's expand and simplify. 8/5 times 8 and 8/5 times 5/8 just disappears to 1, so it's just minus c. Then we have a look at how do we get from O to P. We go OC and C to P. Let's just refer back. O to P, O's there, P's somewhere over here. As I say, we go O to C, then C to P, which is O to C is just the bottom line, and C to P is 8/5 A, take away C, because it's just that. And look what happens, the C's disappear. We're left with 8/5 A, which is parallel or a multiple of just A. Alright, it's 8/5 of A, it's a multiple of A. If it's a multiple, it's parallel to, and it started in the same place. So wrap it up in your own words. I simply went on my model answers. It's a OP is a multiple of OA, hence a straight line. And there we go, tough little vectors to end the paper. Rest of the paper, couple of little nasty things here or there, but overall not a bad one. So anyway, I hope that's helped. Time for me to move on to the calculator paper 6. Might just see you on the next one. Ta-ra!